And the last thing we're going to do in this video set is talk about the derivative as a function. So far we've been talking about the derivative at 2 or the derivative at 3, but if we can do the derivative for any x value, it also makes sense to kind of do it for every x value at once. All right, so we're finding the derivative many times if we care about multiple different points. Doing that whole limit process every single time for every single different number is going to get tedious and it's a lot of extra work. All right, so we're going to figure out how to simplify the process. And the way to do that is instead of using an actual a value, so we had this exact definition before with a's here, because that was the x value we cared about, but instead of using an actual number for a, we'll just keep our variable x. So we're actually going to have two variables in our formula. We don't know what x is, we also don't know what h is, but we want h to go to 0. This is going to give us some expression with x's that represents the derivative function of x. All right, and that derivative function is basically just all of the tangent lines in a function. All right, so let's calculate the derivative of f of x equals x squared. I used x squared for a lot of examples so far, but always for a number. And now we're going to do it with the entire function. But not really much is going to change other than I don't need that yet. It won't let me erase that, so let me just get rid of it. Again, plug in our values. We're just squaring things. All right, and this is actually really similar to what we did with numbers. We just had that extra x hanging around. And now we just square that, remembering to FOIL top. And that thing I keep saying is that you know you're doing it right when all the non-h things go away. Well, x squared minus x squared, those cancel out. And it's good when all the non-h stuff cancels, because then I can factor out an h and cancel that out. And once you cancel out that h on the bottom, that's where you really want to get, because now I can just plug in h equals 0 and just get 2x. So the derivative function of x squared is 2x. And now I can do all these questions at the bottom really quickly, because f prime of 1, well, if my x value is 1, my derivative is going to be 2. So the slope of the tangent line at 1 is 2, because I just plug it in there. F prime of 2 is going to be 4. We've done that before. We've also done this one before. F prime of 3 is 6. All right, so if you just do the derivative once, keeping that extra variable x, then I can pick x after the fact and find all of these slopes of tangent lines, all these derivatives really quickly, because I'm just working with a function rather than this entire limit definition. So really the same thing we've been doing, which is you have extra variables hanging around. All right, so calculate the derivative of y equals 1 over x. So this is one of the reasons we spent 2 units working on limits, is because you always have to start with this limit. And we have to remember all of our tricks and stuff to calculate a limit. So it's going to be 1 over x plus h minus 1 over x over h. Right. So that's kind of just plugging everything in. And now you really have to ask yourself, all right, how do I evaluate limits? What are all those tricks we had from before? All right, well, we have a bunch of different fractions. My goal is going to be a common denominator between those fractions so I can combine them. So my equation is now going to look like that left-hand fraction needs to be multiplied by x over x. And the right-hand fraction needs to be multiplied by x plus h over x plus h. All right, so getting a common denominator. All right, hopefully you know how to do that. All right, but left-hand fraction gets an x on the top and bottom. The right-hand fraction gets an x plus h on the top and bottom. And now I can combine those fractions. All right, we're going to take x, and we're going to subtract x plus h. Well, x minus x is going to cancel out. And I have a minus h. So I'm going to have a minus h on the top over x times x plus h all over h. All right, and this h is going to cancel out with that h. Again, when you cancel that out, you're going to get negative 1. And now we canceled out that h again. Once you ever get to the point where you're canceling out that h on the bottom, that's the sign, okay, now I can plug in h equals 0. I get negative 1 over x squared. All right, so the derivative of the 1 over x function is negative 1 over x squared. All right, so just plug in x plus h, and then just using our limit rules and things we've done with limits before in order to simplify. I'm going to do one more example with the square root of x. All right, just for writing, I'm going to just plug in the h right away. And again, this is where it's helpful to remember all of our techniques from our first 2 units of finding limits. I just a minus sign, not a multiplication sign. The way we did this, whenever we had this kind of square root in our limits, we used the conjugate. And again, we have to multiply it on the top and bottom. On the top, we multiply by the conjugate because it gives us the difference of squares of those pieces. So the square of that square root, the square root just goes away. Then I subtract the square of the next piece, the square root just goes away. And the bottom I'm going to leave separate for now. I'm going to leave separate all the time because I just want that h to cancel out. Again, x cancels out with minus x. I put x, I keep putting x approaches 0 for some reason on these. These should be h's approaching 0. I have an h up there. And again, once you're canceling out those h's, that's the good sign that now I can just plug in h equals 0. I have a 1 on the top. On the bottom, if h is 0, I get the square root of x plus the square root of x, but that just means there's 2 square roots of x. All right, so that would be the derivative of the square root of x function. All right, so same thing for all these. You just have this extra variable laying around, but if you remember your tips and tricks for finding limits from unit 1 and 2, all right, it's the same thing as that, and then simplify so that you can cancel out. Again, all of the problem from the beginning is this h on the bottom because I can't plug in 0. So pretty much your whole goal the whole time you're doing these problems is to, at some point, cancel out this h on the bottom. And then once you do that, you plug in h equals 0 to get your expression. All right, but that's the full derivative, the derivative function for the square root of x. And if I want to find slopes of tangent lines after that, then I just plug it in for that x there. All right, so in class, we're going to practice creating secant and tangent lines, all right, finding their slopes and making the equations. All right, we're going to determine where derivatives do and do not exist based on a graph. And then we'll practice that thing that we did last, finding the derivative of a function using the limit definition. And then once you're able to do all that, you'll be able to slay the day.